Okay, hi, this is lesson 2 on the transformations of graphs. Today we're going to be looking at the ones with a negative in front of the function, a negative in front of the x, and a number in front of the function, and showing what that does. So just to be recap, we should already be probably familiar with these from the past. So if there's a negative right out in front, it means your graph will flip over the x-axis. And the way to remember that is just remember your smiley face and sad face quadratics. If there is a negative inside the bracket in front of the x, then that means that it has to flip the other way. So as long as you remember this one I've got in blue, the minus out the front flips up and down, then the other one must flip left to right. And if you're unsure, please remember the graphs of x squared and minus sine x flipping up and down. So, okay. So normally what I would do is I go plot these in desmos, and if I was in the class and show you them happening as well. So this is what I have got plotted. So let's have a wee look at these. So in this one, the blue is always my original, right? So this is my f of x. And the green one is us sketching negative f of x. Can you see that there's a kind of like a line of symmetry on the x-axis? Everything here has flipped down to here, and everything here has flipped up to here. So this one has flipped up and down, okay? So that's just to prove that the negative in front makes it flip up and down. You know it already though from your x squared and your negative x squared. Here is another one. This time, the negative again has been applied to the full function. So that you started with y equals 2x minus 1. I have times all of that by negative 1, making it this new equation. Again, can you see that it is all completely flipped over the x-axis? Sorry, that blue side has gone up the way. So every single coordinate in blue has now become the same coordinate in green. All right, and this is basically the point it's flipped around. These ones are slightly different. So these are the ones with the negatives in the bracket. So remember my blue line is my original. So if I have only applied the negative to the x, then that becomes negative 3x. The minus 2 stays the same. This time the blue coordinate has been mirrored over that way and mirrored over that way. So if the negative is in the bracket, that means it flips that way. It flips over what's called the y-axis. Okay, so it flips left and right. And here's one more. Now this one's really hard to show. So my original graph of y equals x squared was this orange curve. And I don't know if you can see it, but there's actually a green curve drawn on top of that. Can you see that there if I zoom in? So the green one has been drawn right on top of it. So what's actually happened is it says y equals x squared and y equals f of negative x is the exact same. So remember what we said, that means it just flips left and right. Now if this is already a symmetrical shape, flipping left to right makes it still look the exact same. And also, if you have to work out what negative x squared is, that's negative x times negative x, which is just positive x squared. So they look the exact same, and it's just to do with the symmetry of it. Okay, so for this one this is where you'd probably start copying down. If you were in class, these would be your examples that would draw together. So y equals half x is a upward sloping straight line. Now your most basic straight line is y equals x squared, which goes perfectly diagonal. So I need to make sure this has got a lower gradient than that, but it has to still go through the origin. So I'm going to draw it like this and like that. So there is my line, and I am just going to label this f of x. Now I'm sorry, they're not very straight. I am doing my best. So I'm just going to put a wee asterisk next to that. Was my blue one. And I'm going to do the other one in red. So remember, a minus in front means it's going to flip upside down. So we have to mirror that, but just all going below. It will still go through the origin, still be about the same steepness. So it would go like that. And I'm going to say that that is y equals negative f of x. And that's all you really need to do in the diagram, because in the exam they don't always tell you the equation of it. Sometimes they'll just say this is f of x. So there's our first example done. Let's try another one. So in this one we have to draw x cubed plus 2, and then we have to draw the function y equals f of negative x. So you might remember from the lesson 1 I told you that x cubed and I reminded you that the x cubed shaped looked like this, right? So x cubed plus 2 is that same graph but shifted up 2, all right? So it's your point of inflection like that. So that is it, and it's cutting through the number 2. So this is my blue one, so this is y equals f of x. Right, we have to draw the one where it is reflected. Now, if you can't decide reflected up or down, remember the minus out the front is up and down. So this is the one that is reflected left and right, so reflected over the y-axis. So we're going to do this one in red. So that just means that it becomes going that way there. So this is the graph of y equals f of negative x. And it's just trying to get your head around which way it flips. If you can remember the minus in front is up and down, then the other one must be left and right. Okay, so at this point I would get you to go to the TJ Higher textbook and try page 42, and I would try the selected questions that I've got there. So it's just kind of trying to break down what's there and do one of each style. Right, the second part of the lesson then looks at the graph of y equals kf of x for a positive or negative k. So it could have a minus k in front, which means it will flip upside down as well. But it's just to show what happens when you put a number in front of the function. So y equals kf of x has the effect that it stretches or compresses the graph vertically. So think of your sine graph, and I've got my 3 sine graphs here. So the red one's the original. If you put a 2 in front, it stretches it up and down. If you put a half in front, then it compresses it up and down and makes it not as tall. So if in doubt, you're not sure what that does to, again, think of your sine graph, okay? So again, I would go to desmos, and this is what we'd sketch. So this is what I'm going to show you in the next slide, that we're showing what's happening. Obviously, they both appear together at the same time for you though. So this is the graph. The original one is my blue, and it's y equals x squared. The green one, and I think I discussed this in lesson 1, the green one is y equals 2x squared. Now, I know we said it stretches or compresses up and down the way. At first glance, this looks like it's made it narrower, doesn't it? But the reason that is if you think of the equation y equals x squared, if you plugged in the number 1, you would come out with the number 1. But if you plug number 1 into y equals 2x squared, it becomes 1, 2, right? So the 2 in front is basically, it's doubling the x, so your y is becoming double the height. So it's actually stretching your y coordinates up and down the way. So all your important y coordinates become higher up. This one here that would have been a 2, when that goes in, that becomes an 8. Now that just doesn't fit in my diagram, but that green line, remember that green line keeps going. It's a continuous thing. This is just where I happen to cut it off taking the picture. So the x squared one is a bit confusing, and if in doubt, try plugging in a couple of coordinates just to remind yourself. So the x squared one, it stretches your graph, so it does get thinner, and that's a bit off-putting. Okay, so in this one here, apologies, I've had to go draw that green line in by hand there because there was a wee mistake on it. So my original function was y equals 2x plus 1. I am now multiplying that by 3. So that makes the equation 6x plus 3. So when we draw that, because the gradient's gone from 2 to 6, it's definitely a steeper line, and your y-intercept has gone from 1 to 3. So can you see that that has stretched your graph up the way again? So it's taken all the points on this blue line and pulled them up a bit, okay? So that's what it's done with that. So it's stretched the line up and made it a bit steeper. So this is us going to draw some of our own now. So on the same diagram, we are going to attempt to draw all these lines. Now this is going to get a bit messy. So first thing we're going to draw is the line y equals 2x plus 1. So I'm just going to remind you, remember you've got this line, this is the line of a gradient 1. So gradient 2 has to be a bit steeper than that, okay? And plus 1 means it's going to go through plus 1 on the y-axis. So I'm going to draw it steeper and going through 1. So that will do, okay? So this is going to be labelled f of x. Right, next it wants me to draw 2f of x. So 2f of x would just be turning that into doubling it all. So that would be 4x plus 2. So this would move my y-intercept up. It would also make my line a lot steeper. So let's draw that now. So, oh God, does it look steeper? It does look slightly steeper, so that will be okay. So that is 2f of x. Right? I'm then going to take a different colour pen. I'm going to take the green and we're going to draw half f of x. So half f of x would be half in both of these numbers. So that would be x plus 0.5. So it's got a lower y-intercept. Can you see how it's stretching and compressing the y-coordinates? And it wouldn't be as steep as the dotted line I put in. So it would be like this. So that would be a half f of x. And then the negative 2f of x is basically that red one, but flipped upside down. So negative 2f of x would be negative 4x, and it would be negative 2. So it would be cutting down here at negative 2. And it would be obviously trying to make it as steep as that red one. This is going to be fun. So that's nowhere near. Let me try again. So if I draw it that way, that might help. Obviously, you would do this in class with a ruler, right? And it would be a lot easier. So that would be negative 2f of x. So I apologise, my picture isn't brilliant. There's one more thing I should probably do, and that is label that was number 1, that was negative 2, and then that was 2. And I know they're all on different sides of the axis, but do you know what? There we go. We'll put them all on the right side. That looks better. Okay, so it does get messy, but in an exam you're never asked to draw 4 in the one diagram. At most it's an extra 2, and the first one's already drawn for you. Okay, second one, right, now we're going to do it with the cos x graph, and then we're going to draw 3f of x and minus 2f of x. First thing I've noticed is this diagram I've got here is completely the wrong place, so I need to try and move this. So we are going to move this over here. Okay, so that's a bit better. I'm ready to draw now. So first things first, I'm going to do the graph of y equals cos x. So cos x is the graph that looks like a wee hammock. So it's going to go like that. It's not the best. It goes from 1 to minus 1. Okay, so this is the one in blue. So this is f of x, or cos x. And then that would be at 360. That would be at 180. And that's probably enough that I need to put in my picture. Then I am going to draw the graph of 3f of x. So that means it goes from 3 to minus 3. So that would be a lot taller. I'm going to just give myself a wee bit more room. So this would be a lot taller. So it's going to go from 3 right the way down to what I would imagine to be minus 3. And still cutting at the same places and come up and still finishing at 360. And then I'll mark on my picture that is 3 and minus 3. So that is 3f of x. And then the last one I have to draw is the graph of negative 2f of x. So that means it's flipped upside down and it goes from 2 to minus 2. Still going through the same points. And this is so much easier to draw because we're familiar with what these graphs look like. And that is negative 2f of x for that one. Okay. So at this point you're able to go to page 43 of the TJ Higher textbook, and I would do question 3 onwards, and I've said selected, so don't need to do every single one, but pick and choose, maybe do one of each style.